Hey guys! Welcome back to my channel. If you like my videos, please like and subscribe. Today we're going to be reviewing what slope is, how to find the rate of change, and what slope-intercept form is. Let's get started. So if you remember, the formula to find slope is y2 minus y1 over x2 minus x1. So let's say we have these coordinate points right here, and we want to find the slope of these two coordinate points. So to solve this, first we're going to have to take y2, or the y value of the second coordinate point, which is 13, minus y1, which is the y coordinate of the first one, which is 4. So 13 minus 4 over x2, which is 6, minus x1, which is negative 2, so minus negative 2. So to find the slope now, all we have to do is just simplify this expression we have here. And so over here, 13 minus 4 is equal to 9. And 6 minus minus 2 is the same as 6 plus 2. So 6 plus 2 is 8. And so our slope for this one would be 9 over 8. So that's sort of just like a quick review on how to find slope through coordinate points. Let's move on to the next one and see what rate of change is. So now we're looking at rate of change, and rate of change is basically just slope with labels. So what I mean by that is basically the problem will give us an independent and a dependent variable, and basically it'll give us a situation to go with it so that we can write like labels at the end. So instead of writing just like 24 as a slope, I would write say 24 bottles per minute. Something like that. If that was the particular situation, I would write 24 bottles per minute instead of just writing 24. We'll see some more detailed examples of rate of change on the next page. So now let's move on to slope-intercept form. So slope-intercept form is basically just an equation for a line where the slope is written as one of the variables inside of it. So slope-intercept form is really equal to y is equal to mx plus b. So this is the formula for slope-intercept form, where y is y, x is x, and the m over here is going to be the slope. And the b over here is going to be the y-intercept if it was graphed on a graph. So this is slope-intercept form. So if anyone ever gives you an equation, say like this one right here, you can immediately tell what the slope is because this equation right here is written exactly in slope-intercept form. So whatever number comes right before the x, whatever the coefficient of that x is, that is what the slope is going to be. So for instance, in this equation, the number 7 is before the x. So for this one, the slope is equal to 7. And the y-intercept, if we wanted to find it, would be negative 4. But the main point to take from here is that the coefficient of x, whenever a line is in slope-intercept form, means that the slope is just that coefficient of x. So now that we've gotten sort of a brief review of slope and what rate of change is, including slope-intercept form, let's move on to the next page to do some practice problems so we can really get like a deeper understanding. So let's go to problem number 1, which says to fill out the table. So over here we have rate of change on the right side, which means we'll have slope on the left side. And whereas slope is usually just written as a plain number, rate of change is written as a number plus any labels it might have. And whereas rate of change needs a word problem or a situation, slope actually does not. It does not apply to slope. So using this table, let's move on to the next problem. So problem number 2 says to find the slope of the following. And so the first one is pretty basic. It's sort of like the one that we did in the page before. So remember, it is y2 minus y1 over x2 minus x1. So y2 is 16 minus y1, which is 4, over x2, which is 9, minus x1, which is 3. So 16 minus 4 over 9 minus 3. So this is our slope, but remember we need to simplify this. So 16 minus 4 gives us 12 over 9 minus 3, which is 6. And so 12 over 6 can easily be simplified into 2. So that means our slope for this one is 2. For the next one, we can see that this is an equation. And remember, when we get an equation and we want to find the slope, well, all we have to do is put it into slope-intercept form. If you remember what slope-intercept form was, it was y is equal to mx plus b, where m right here, or the coefficient of x, is going to be the slope. And so all we want to do is sort of just rearrange this equation right here so that y is on one side alone. So basically, we really just have to solve for y here. So to do this, first what I'm going to do is subtract 3x from both sides to get the y variable alone. And so 3x minus 3x leaves us with nothing but negative y, which is going to be equal to 24 minus 3x. So 24 minus 3x. And now you see that this is a negative y, but we need the y to be positive. So what we're going to do is just multiply both sides by negative 1. The reason we multiply it by negative 1 is because we want to change the sign of the y here, because negative 1 times negative y is going to give us a positive y. And the reason we choose negative 1 is because the 1 won't change the value of any of the numbers. So if I multiply 1 by y, it's just going to give us y again. And if I multiply 1 by 24, it's just going to leave us with 24. So it won't change the value of any of the numbers, which is why we're multiplying by negative 1. So negative 1 times negative y leaves us with y, which is equal to negative 1 times 24, which is negative 24, and then negative 1 times negative 3x, which is going to give us plus 3x. So this is our simplified equation right here, but we sort of need to rearrange this to get it into that y is equal to mx plus b form, because the x term should be before the constant term, which is negative 24. So instead of writing that, I'm going to just rearrange the right side to make it look like y is equal to 3x minus 24. Just sort of rearrange that so I can get it exactly in y is equal to mx plus b. So now over here, all I have to do is look at the coefficient of the x term to find the slope. And so if I look at the whole x term here, the coefficient of it is this 3 right here. So that means our slope is 3. And that is our answer for this one. So if you look at this next one on the graph, so to find the slope on a graph, you use what is called rise over run. So basically you find 2 points on the graph. So let's say I choose negative 2 comma 0 and 0 comma 4. Those 2 points right there. And now we look at how much you rise from the first point and then how much you run from the first point, all to get to the second point. So first we have to look at the axis, and we're counting by 2s. And so I rise 2, 4. So I rise 4, and that's going to be rise over run. So after I rise 4, I run 2 to the right to get 4 over 2. So all we have to do now is we just simplify this. So 4 over 2 is equal to 2. So 4 over 2 is equal to 2, and so 2 right here would be our final slope. So our slope is equal to 2. Now that we have found the slope of these, let's move on to problem number 3. So our first one over here says in 2001, Linda purchased a house for $144,000. In 2016, the house was worth $245,000. Find the rate of change in dollars per year for the value of the house. So remember, rate of change is usually situated in a word problem or a situation, and it includes not only the number but also labels at the end. And so over here it's asking for the rate of change in dollars per year for the value of the house. So that means every 1 year, how much did the value of the house go up? So over here we can write this as 2 coordinate points. For the x variable, I'm going to use the time or the year, because the time or the year is the independent variable. So that's going to be my x term. So for the first one, our x term is 2001, and in 2001 the house cost $144,000. So that's our first coordinate point. Our second coordinate point is when in 2016 the house was worth $245,000. So now that we have these 2 coordinate points, we're going to find the slope of them. So remember, the slope formula is y2 minus y1 over x2 minus x1. So y2 minus y1 is the same thing as 245,000 minus 144,000. So that's going to end up giving us 101,000. And remember, y2 over y1 is over x2 minus x1. So in this scenario, x2 is 2016 and x1 is 2001. So 2016 minus 2001 gives us 15. So this right here is the slope, but we have to simplify this. So simplified, we're going to get around $6,733.33. So this is the value that the house goes up for every year. So to find the final rate of change, how we're going to write it is that we're going to say that each year the value of the house increased by $6,733.33. So this right here is going to be our final answer as the rate of change. That the value of the house increased by $6,733.33 each year. Now that we've got this, let's move on to the next problem. So our next problem says that a climber is on a hike. After 2 hours, he is at an altitude of 400 feet, and after 6 hours, he is at an altitude of 700 feet. What is the average rate of change? So over here, remember, time is our independent variable, so that is going to be our x component. So basically, we're just going to do the same thing we did up here. So with our 2 coordinate points, we have to find the slope. And remember, y2 minus y1, or in this case, 700 minus 400, gives us 300, over x2 minus x1, in this case, 6 minus 2, which is 4. So 300 divided by 4 is our slope, but remember, we have to simplify. 300 over 4 is equivalent to 75. And so 75 is our slope right here. So to write this as a rate of change, we're going to say that the climber rose 75 feet per hour. So this right here is our final answer. That is our rate of change. The climber rose 75 feet per hour. So that's it for today, guys. If you want more videos like this, please like and subscribe, and be sure to comment any other topic ideas or any questions you have in the comments section below. Also, be sure to follow me on my Facebook and on my Instagram. Thanks for watching. See you next time. Bye!